Now we're going to look at using SPSS for two-sample hypothesis testing. In this case here, as in section 8.2, there are going to be two independent samples. And so here we're doing the two independent sample t-test for the difference between means. We have these two samples, and we want to know how do the means of these two populations compare? How do the mu's from these two populations compare based on the information we have from these two samples? So let's take a look. So consider the weight gain of 19 rats between 28 and 84 days after birth. 12 were on a high protein diet, 7 on a low protein diet. So we've got this high protein diet here and this low protein diet here. These are our two samples. So let's set this up. Well, first we have to say what these things are. So let's set mu1 be the mean weight gain on high protein diet. So this is going to be diet 1 for our measure, for the way we're noting this. And mu2 is going to be the mean weight gain on the low protein diet. So this is going to be diet 2. Okay, so it wasn't specified here, but we're going to go ahead and let alpha be 0.05, and let's set up our hypothesis test. Okay, so let's say that let's make a claim. Let's claim that there is no difference in weight gain. All right, so there is no difference in weight gain should mean that the mu for both of these is the same. So that would be saying mu1 equals mu2, and this is our claim. So we're making this up. And then mu1 not equals to mu2 would be our alternative. Okay, so we have it all set up, and let's see what we can do. So the first thing would be to actually input this all in SPSS. So let me go over there to SPSS, and I've got all that data input there. Now, take a look at how we have to do it here. We have gain, so we have all the data here of the 19 cases broken down, where the first 12 here are from diet 1, the high protein, and the second 7 are the low protein diet. So all of our data is listed in that one column, and then we distinguish which group is which. So diet 1 corresponds to all the gains from the high protein, and diet 2 corresponds to the gains from the low protein diet. So that's the way we have to structure it here for our two-sample test, for our independent two-sample test. So next thing we do is we go to Analyze. This time we're still going to compare means. This time we're going to the independent samples t-test. Click on that. So now we have to tell it how to interpret this. So let me bring this stuff back over because that's where it would start. So we have two categories here. We have the test variable and the grouping variable. The thing we're trying to test is the weight gain, so that goes there. Now the diet, that's how we're grouping it, which diet. So we go over there and we have diet, but now it has question marks in there, so we have to define the groups. So this normally wouldn't be here, so I put 1 here in group 1 and 2 in group 2 to distinguish which diet I'm referring to, which diet is going to break it up. Alternatively, we could do it by a cut point in the data, but let's do it by the way we have it here. Okay, so then I continue. Now everything is set up with my test variable, my grouping variable. I click OK, and then out comes my data here. So let's take a look at what we have. We have a bunch of group statistics based on diet 1 and diet 2, the number, the mean, standard deviation, all interesting statistics from there. Here's where we want to go. Okay. So in this independent samples test, we have a lot of information here. So let's look through it. Now, if you remember, we always had this idea of what to do if the variances are equal or not from the populations. It didn't say anything about that in the problem. Well, that's because the data can tell us what we should assume. So this here, Levine's test for equality of variances, is going to tell us whether or not we should go with the equal variances or unequal variances. So we start on the premise that we're assuming that we can use equal variances. So this is an F test here, like a t-test, but slightly different. And it's giving a certain significance level. So this is a p-value. So all we have to do is look at this p-value here, this 0.905. Again, we'll use alpha equals 0.05. If this significance level is less than 0.05, that's saying that we should not go with equal variances, and instead we should go to the second row here and use that. But because this is greater than 0.05, a lot greater than 0.05, we're going to go and we're going to assume equal variances. So we're going to use all the data in this row here, and we're going to ignore the second row. So then we go over here, and here's the information. There's our t-value, the degrees of freedom. All right. Here is our two-tailed p-value. There's the significance right there. Again, some more information, but we want to focus on this right here. So let's go back to our information sheet here. So let's just recap. We input the data. We chose the test here, the independent samples t-test. We chose the variables, where to put them, and how to define the groups. And then we got this output here. Okay, so this is the output we got. And now let's break it apart and make a conclusion from here. So once again, let me recap. Because this was greater than 0.05, that means that I can go with the equal variances. So I'm going to be using the first row here. All right, so as we can see, we ended up here, there's our p-value. So we did do, this was, remember, h0 was mu1 equals to mu2, and so this is a two-tailed test. So we are going to use that as our p-value. So 0.076 is our p-value. We set alpha to be 0.05. We have the 0.076 is greater than 0.05. So we fail to reject h0. And again, let's go back. Here was our hypothesis test with the claim in the null hypothesis, meaning we're in rejection mode. So, and we did not get the data to reject h0. Therefore, there is not enough evidence at 5% significance level to reject the claim. Specifically the claim that the mean weight gains are equal. We haven't shown that we can say that they are unequal. We've said that there is not enough evidence to reject this claim.